dots one.
Yeah.
Okay, now I'm recording on both.
Sweet. Do you want to say the acknowledgement again?
Yeah.
Sweet.
Okay, so I would like to begin by acknowledging the traditional custodians of the land on which we gather today and pay my respects to their elders past and present. I extend their respect to Aboriginal and Torres Strait Islanders people here today.
Sweet.
Awesome.
Alrighty. So activity 1.
So for this one, I think we don't have to have a look at those, like the variables and things like that, because it's a modeling.
I think we just engage through a little bit of a discussion to begin with.
Did someone want to open up that document so we can have a look at the questions through there?
Did one of the production people want to put it on the screen like I did last week? Screen share.
Claudia, do you want to do that while I'll record it?
Sure can.
I think when we go through the setting up, I briefly discuss the CDSU, but after you guys try to explain it, and then I chime in.
Yeah. Awesome. How do I share my screen? Does it say?
I think
that's working.
no. Can't see your screen. It's the one that says share content. It's like the box with the arrow in it.
There we go. Alright, let me try that again. Can you see it now? I can just see you, Claudia.
Yeah, I can't see anything.
Says it
Technology.
Alright.
I could just read out the questions on the activity sheet
Says it sharing
because I have it up.
Just start going through it. That's all right.
Just where it says activity 1, then engage phase.
Yeah.
All right. Yeah, no worries. I can do that. So, work with your group to discuss what sedimentary rocks are. So, what are they? Anyone? No? Maybe what do they look like?
They're like an accumulation of different types of rocks, like together, rather than just one type of mineral or particle or whatever.
Anyone else?
I mean, I've read kind of through the experiments, but I kind of agree with what Morgan said about like it's different rocks, but that's just from my knowledge of like reading up what we're going to be doing today.
Yeah.
Sorry, but that's all I really know about it to start off.
Isn't it when all different rocks like join together?
Yeah.
This is tricky because I know the answer, but I can't say it.
Yeah.
And then I guess the last one is how they formed, which probably not many will understand yet.
Yeah, that's hard.
Is it through? I'm going to guess. Can I guess?
Mm-hmm.
Is it through like weathering and erosion?
I can't give you the.
But you say yes or no? Maybe.
Yeah, maybe.
They can form in like chemical ways. Hey, it's a chem.
All right.
So like the smaller minerals and things like that kind of like form together around the bigger ones. So like they take up the spaces between the bigger particles to form like one big rock or whatever.
Sweet. Alrighty. So setting up the activity. Who's on the activity again?
It's me. So
Do you want to go through it?
yeah, of course. So
Sweet.
for the materials, what we needed, I'm just going to quickly show them. So we got 3 different color Play-Dohs. We got blue, yellow, pink. We need 1 clear drinking straw cut into 4 small pieces. 1 clear Ziploc bag. 1 small cup. A pestle, I think that's how you say it. And then pestle, yeah, there we go. And then 1 water bath. It's in a little container.
Yeah.
And I was able to measure it because with my mum's coffee machine, it comes out with like what degrees it is. So I put it at 60 degrees, which is what they recommended doing it around.
Mhm.
And then if we just want to look at the initial hypothesis. So I wasn't sure if we needed to do 1 for activity 1 and 1 for activity 2. What do you guys think? I think that might be best because it is 2 different.
It's 2 different. Yeah, 2 different types of rocks.
Yeah.
So definitely be different hypotheses, whatever. Yeah.
So what were we thinking for activity 1? So I'll just quickly explain what activity 1 is. So what we're going to be doing is we're going to be picking colors and making them into things like different things to represent either it's like the effect of wind, the effect of water, and the effect of representation of small rocks. And then we are mixing them kind of all together. And then we're taking like a little core sample with the straw and just like observing and taking notes of what it kind of looks like. Oh, and I have to use the pestle to lightly like pressure on it to like kind of combine it together. And then with the water, we're adding the Ziploc bag with the Play-Doh in it into the water, and then we're looking at the effects on how the hot water kind of changes it. But yeah, so for the initial hypothesis, what do we think?
Am I allowed to discuss this with you? Because I know like the answer. Probably not.
I think you can a little bit. I'm
Looking at what's going to happen when they mix together. Is that what?
Yeah, we're doing the first one.
so for activity
first one, yeah.
If you could say if the 3 different
Play-Dohs.
Play-Dohs
Materials, yeah.
are compressed together with pressure, then what do we think might happen?
The colors will mix
they'll mix
together.
They'll combine together.
Then they will combine. We'll combine together because
See, you guys don't really know the
Yeah,
seriousness
right. Yeah, we can't
behind
really
it.
say it
Yeah.
because Callum could say it because.
I could, yes,
could
but
we guess
it
why we think the colors will all come
Yeah.
together?
yeah, why do you think it would be squished together? Like, what do you think will happen?
Because there's like pressure being applied to them.
Yeah, I think that's a good way to say it.
Yep. We can write that one down.
Force.
Sounds good.
And then for activity 2, what do we think? So I was thinking if heat and pressure
Are
So
applied
We're putting it in
to
water.
cut in.
We're putting it in 60-degree water.
Yeah. So
Yeah.
So where does the pressure come from? The water?
the pressure comes from the squeezing from the person doing the experiment, I think.
Oh, okay.
Sorry, I didn't go into much detail, but I would further on about that. We have to squeeze
Yeah.
the flag.
Yeah.
Okay.
So if heat and pressure are applied to the Play-Doh,
Then
Then do we think kind of like the same thing will happen?
I don't know. Are we putting the same amount of pressure on that we're putting on the first one?
No, it's probably a bit more pressure because you actually have to squeeze the bag together.
Right.
So
Then,
whereas the first one is probably a little bit light.
Maybe the first one would be more like the colours would kind of just compress together, but not really mix
Yeah.
as much as the second ones where like the water the heat of the water could like change the consistency of it too.
Yeah.
So
I
that
reckon as well the second one,
Definitely
like
write that
following what
down.
Morgan's saying, it might change colour. Like you know how when kids mix Play-Dohs together, it
Yeah.
makes that awful brown colour.
Yeah.
yeah, because if the consistency is like different, then it will be easier for it to mix together.
Yeah.
We're definitely looking at the change of it.
I don't know how you word that. Though. That's hard.
If heat and pressure applies to Play-Doh, then the Play-Doh colours will combine together because the consistency of the Play-Doh has changed.
Yeah.
Will change, yeah.
Yeah.
And then for the first one, I've just put, if the 3 different Play-Dohs are compressed with pressure, then the Play-Doh colours will compress together because pressure is being applied.
Just
Sounds pretty
quickly, Kate, on the RHS, the activity name and research question are still from last week. I don't know if you want to go over that quickly.
Oh, yeah. So I'll quickly write it as well. It's just
I guess we're exploring
What will happen
Sedimentary
when
rocks.
pressure and heat are applied to whatever?
there's not really a research question, but we meant to come up with a research question.
Yeah, you
probably are.
with our own.
Okay, so what are we thinking with a research question? I've completely
Morgan just said a good one. You must
What
have
did you
missed
say,
Morgan.
Morgan?
I said, what will happen to what is it like Play-Doh?
Yeah,
Yeah.
Using Play-Doh.
If heat and pressure are applied. I don't know how to finish the sentence.
If heat and pressure are applied in different ways, you could say.
Claudia, are you talking?
Yeah, can you hear me?
Oh, I couldn't hear you before.
Oh.
I can hear you now. Because I could see your mouth moving, but I couldn't hear anything.
What'd you say, Claudia?
I didn't actually say anything. I don't know why. Maybe it's lagging from before.
Oh, okay. Sorry.
All right.
Alrighty. So I've already kind of written down the materials and the equipment. So now the health and safety. What do we think a risk could be?
Definitely the hot water.
Yep.
Yeah.
The Play-Doh in their mouths and stuff.
Yeah, definitely.
I know last week we didn't go over it, and I know it was in one of the feedbacks she did, but we do need to discuss what would the teacher actually say.
Yeah, I did
Yeah.
put that in the Teams message thing. So we actually have to kind of say what would the actual teacher say.
Yeah.
Yeah,
Um,
specific quotes.
Another thing I was thinking of would be maybe allergies to the Play-Doh.
Yeah.
So
Yeah,
gloves.
definitely.
I don't know, like if kids could be allergic to it.
Like even
Right.
especially if it's homemade Play-Doh as well, like gluten and the flour and things like that.
Yeah.
I think like what's it called? Pestle thing?
Yep.
Like
Yeah, that could be dangerous.
squishing their fingers or something like that. Like doing dangerous things with it, like holding
Throwing it.
it around or throwing it or
Yeah,
whatever.
I think one of the best things to put in what would the teacher actually say is what she says all the time is don't eat it, don't drink it, don't use it as a weapon.
Yeah. And then you just reiterate like classroom expectations.
Yeah.
So then if we're worried about like allergies and things like that, as well as with COVID and germs and stuff like that, would we say that they need to wear gloves when they're handling it?
Yeah.
Yeah, I would
So
say
that's something like as the teacher, you just say to them like, you need to keep your gloves on the whole time until you're told that you can take them off.
Yeah.
Pretty much.
That could just
Like,
completely.
Normal gloves
Go
or like ones for heat as well because they are touching a hot container.
It could be those like lab ones that are
Mm.
like double thick, you know, those thick ones.
Yeah.
Just that we can also
Because
use
it's
that.
not like too
Oh.
hot to the point where they're gonna like.
But it would definitely
It would
would
be
hurt.
it would be hot, but like it wouldn't be like you couldn't touch
3rd-degree
the
burns.
container.
Yeah.
Yeah.
Yeah, because could the heat melt like the plastic of the gloves? Is that what the gloves would be made
Mm.
out of?
Yeah.
Mm.
So we could just like talk about the controlling of temperature.
Yeah.
If anyone wants to like start writing some stuff for the health and safety thing, I'm writing as like much as I can from what I'm
Yeah,
hearing
on
from
it
you
as
guys.
well. I'll write some stuff down.
But I'm trying to listen while like typing some
Yeah.
other stuff. So I'm like, I've missed half the things that we've said. Sorry.
Right.
There were health and safety questions in the experiment document.
Yeah.
Pretty sure.
Yeah.
I wasn't sure like if we really needed to answer them or like if we're doing this health and risk and safety thing previous. Like it's more for I don't know whether the students are wanting like the students to answer these questions or if it is for us to be answering the questions, if that makes
That's good.
sense.
Yeah, that makes sense.
But I think we can always like I'll like read everything out from here and we can just answer it anyways, just to be
Yeah.
on the safe
I reckon.
side.
I think that's a good idea.
Because you just hate for something to be missed out on.
Mm.
Yeah, because I definitely want you to discuss like in the setting up the activity, like the CDSU.
Yeah.
So they really want the collaborative discussion. All right. Any more health and safety?
Just having a look now.
Obviously, the eating can go into choking as well.
Yeah.
A health and safety one as well could be like movement around the room.
Yeah.
Like if they have to go and collect the water from anywhere, then when they're walking back to their desk.
Definitely
like,
minimize that.
As a teacher, you probably like again, like we discussed last week about giving students roles, so not everyone's moving around the classroom.
Yeah, I think
There's
that's a
only
really
like
good idea.
a small number of people moving.
Manager, director, speaker.
Or even having the water set up at the tables ready to go so that they're not
Already,
trying to
yeah.
move hot water.
Yeah.
I agree with that.
Yeah, like the teacher handles the hot water and then the kids do the like pressure or something.
Yeah.
Make sure that there's not too much.
I think that this, like, do the kids do this experiment or is it just an experiment that the teacher, like, does models for the students?
I think it's a modeling one.
That's what I was wondering, whether the kids even do it or not, or if it's just like the teacher does it and the kids are kind of just observing what's happening.
It could be both.
Yeah, that's why I'm like,
Yeah, so they're modeling
I have a lot of
demonstration rather than full investigations.
and they have a lot of like reflective questions after each like image kind of thing.
Yeah.
But anyway,
I mean, like a piece of Play-Doh could drop off the floor and someone could eat it still. So I still think like it needs to be like you just never know. Like some kids are like naughty and can get the Lego and all Play-Doh. I mean, sorry. Especially if you're doing this like with younger kids.
Yeah.
They could see Play-Doh as food. Really.
they all just want to play with it. Like,
Yeah.
yeah.
Alrighty.
so setting up the activity, is that what we're up to?
Yeah, I'm just going to
Yeah,
quickly
sweet.
copy and paste the procedure into this document because I've done it beforehand, but apparently we weren't allowed to put it in until we discussed it. But I didn't want to like write it up this whole time while we're talking about it. So I'll go over what we're doing in a little bit more detail. So, and I'll do it at the same time.
Should
All
I
right,
pay
so-
to the big screen now, or
Oh, yeah, sure.
how do I do that?
Oh, God.
You could just press
Yeah,
on
we could just
her.
tap
Oh,
on her and
You're giant now.
Well, alrighty. So the first step is we have to choose one color and roll it into little balls to represent small rocks. So I picked the color pink. So just roll it up into small balls. If you guys can see, example A. is pebbles, and I've written on my little piece of paper pebbles, just so if you're doing this as a teacher, you can let the students know, see like that these are the pebbles also. Then choose another color to represent the effects of wind. I picked yellow, and then there was just I did it into like small little flat shards, so it's more eroded sediments.
Cool.
And then I've also done that one already, just so we didn't have to waste too much time of me pulling the Play-Doh apart. I lost a pebble. And then the last color represents effects of water on the soil's bottoms of a river, which is formed, which is often moved by the water in layers. So I picked the color blue and I just made it into mud. So I'll give a really clear. I lost my pebbles. Oh no. I'm sorry. There, so you can see the mud, the yellow, and the pebbles that are left. Right,
Should we discuss, in the brackets each thing?
Sorry. So with the pebbles, it asks us, use your notes to discuss what the terms pebbles actually mean. And then it has what is a CDSU.
So should I chime in after you guys discuss?
Yeah, I think so. I
What
think
is a pebble?
yeah. So what is a pebble? So what do you guys think a pebble is?
A
Small rock.
rock.
Yeah, that's what, when I looked it up, like I did a little bit of research, that's like mainly what I could come up with. If that's kind of similar to what you have, Callum.
Yeah, basically pebbles are defined as little rocks that are made up of pieces of pre-existing rocks.
Yeah.
So there's like little tiny rocks basically,
Mm-hmm.
and they break down into rocks from weathering processes.
Yeah.
Was I right with weathering?
Yes, you were. I just couldn't tell you yet.
I'm trying to turn the camera this way so you can kind of see it all. And then, hold up, there's a question. And then with the choose another color to represent the effects of wind on the Earth's surface, it has discussed what name given to this process. Discuss what name given to this process and how you might represent it with the Play-Doh. So, I just kind of saw the pictures and saw that it did like the eroded sedimentation. So I was like, oh, look, I'll do something similar. But when I was thinking about it, you think of like the way the wind has effect on the earth. When you think of wind, everything's kind of blowing away and all that jazz. If anyone else wants to.
Yeah, so wind causes the erosion.
Yeah. So
Would you say that like it causes really fine particles to be like picked up and swept away?
yeah, I would say that. Yeah, I definitely would agree with that.
Anyone else?
So yeah, how we represented in Play-Doh, I kind of broke up the Play-Doh into small little pieces. Yeah, there you go.
Sweet. So yeah, it was erosion and weathering. That's the process of it. The effects of wind. It's mostly wind and rain, and they do break down larger rocks. So yeah, particles into smaller ones. So you could say boulders, and then because of erosion and weathering, they'll break down and fall.
Awesome.
Hey, Kate.
Yeah.
Just for the data and recording that Morgan and I are doing, can you take a photo of the all the Play-Dohs before you mush them together?
Yeah.
Thanks.
And then with the third color, which is the effects of water on the soil at the bottom of rivers, which is often moved by water in layers, it has discussed what name is given to this process and how you might represent it with Play-Doh. Again, I kind of saw they did mud, so I just followed that really. If anyone else knows what the name is given to this process of the effects of water on soil at the bottom of rivers. I wasn't too sure myself.
Yeah, I'm not sure.
Me either.
Should I just chime in now?
Yeah,
Is it
go
something to
ahead.
do with like sediment something?
Yeah, keep going.
I don't know.
So yeah,
Sedimentation.
Yeah, that's
it's
the
called
word.
lithification. And it's
Called
the
what?
process lithification.
Oh yeah.
It's a big word. It's an annoying word. But it's the process by which either sediments, so rocks, sand, or clay, or soil, at the bottom of the ocean, or like bodies of water or rivers, in the example given, they're compacted and cemented into rocks from the overlying sediments.
So is that from the pressure from the water?
Yeah, the pressure of the water, and then the sediments compact together, and then they go into bigger rocks, basically.
Awesome. So then the next step is so place an empty Ziploc bag into the small cup.
Should we talk about how we're going to record the data first before we start?
Yes,
Yeah,
that's a good idea.
Yep.
In the actual thing, once like it does do a few things, it kind of says discuss what you might find if you press everything in the Ziploc bag together. What 3 points do you think you find? And then it also does ask you to like document and describe observations and look at patterns with what you are seeing. So that they're in the steps. But if you want to discuss how we're going to kind of do that, that'd be great.
Morgan had a really good idea earlier. If you wanted to share that, Morgan.
Yeah. We were talking about having some sort of like worksheet, or they could even draw it up themselves, of like a section that says what they think is going to happen.
Yeah.
And then another section where they can afterwards write what actually did happen, and then a space for them to kind of like draw and write what they observed during the process.
Yeah, that's a good idea.
I think as well, like not trying to jump the gun too far to like the end of it, but it really like you could use it as a teacher for like formative assessment as well, to see their scientific understanding develop over the course of the term or whatever you're doing. You can really see how they think and what language they used and all that kind of jazz.
Compare their pre-observations versus second observations. That's a really good idea.
That is a good idea.
Sweet.
All right, so place the open-ended Ziploc bag into the small cup. Place the rocks. Placing the rocks. The erosion and some of the mud into the Ziploc bag, and then it says randomly add the rest of the Play-Doh into the open Ziploc bag. So make sure to just have like an even amount, I guess. So, all right. So it's all in the Ziploc bag in the cup, if you guys can see. Alrighty, and then it says use the pestle to apply pressure, into the Ziploc bag, and then use the pestle to apply pressure into the contents of the cup. Do not squash or flood it, as you need to take a core sample. So I'm just getting me a little pestle, and so I'm just applying a little bit of pressure. If you guys can see, not really squishing it or anything, just a little bit of pressure here and there. And then open that Ziploc bag. And then so now we need to take out a core sample. So the way I'm going to do it is just getting that little straw, kind of placing it in, using one of the straws, going from top to bottom. And then a little bit came out. I don't know if you guys can see. Yeah, you can kind of see the colors are like, they're not mixed together to make one color, but they're definitely like intertwined with each other.
Yeah.
And then choose another place. So I pick another place of the sample and do the same thing. You guys can see. So it's got a bit more there.
Oh, the other side looks cool, like where it's kind of gone green.
All right, and now it's asking us to observe and discuss any observations or patterns. So from what I can see, like I've said before, like the colors actually haven't really mixed into one,
They're kind of layered.
but they are layered,
Yeah.
and you could see that there is a little bit of a mixture in the second sample of green, like Rachel kind of noticed.
Yeah.
But it's not like the colors, it's not like blue, pink, yellow. The colors are
No.
together, but they're just not formed one color or anything like that.
I think if you had to separate them back into their 3 original colors, I don't think you'd be able to, though.
No, you definitely wouldn't be able to put them back into the original colors. Once they're like this, mixed up all together, they're not gonna change. Did you guys want me to take a picture of these as well, Rachel?
Yes, please.
All right, I'll quickly just take a picture. Alrighty, so now we're on to activity 2.
Should we do a final hypothesis for that one?
Yes.
Oh, yeah.
Just about to say there are some questions. Sorry.
I need to do that one.
Oh, do you need to do the questions?
The final hypothesis I need to do.
Okay.
Yeah.
So just questions to think about. It has how are the 2 samples different and how are they the same? So I guess one sample was a bit bigger. We did get a lot more out of the one sample.
They do follow kind of the same pattern of, layers.
Yes, that's very good to observe. And then how do the samples reflect the way the rock was made?
Did you say how does it reflect the way that they're made?
Yeah, how does a sample reflect the way the rock was made? So I guess it's like a now
shows that like in the one rock, there's the different types of
Sediments.
Yeah.
like particles or whatever we're going to call it.
Yeah,
But different areas may have like different amounts of like different particles.
yeah. And then it says, how could you determine if the sample was sedimentary rock sample? Oh, sorry. I cannot say that word correctly.
Yeah, it's a tricky word, sedimentary. It's weird.
There we go. How could you sample was sedimentary rock sample? There's a lot of samples, but
I guess if you understand how it's formed, you can tell. But also,
You could
if you look
see
at
like the different size particles.
yeah,
Because I think
because
like in sedimentary rock, like you can see like the big pieces and then like the small pieces that are in between. And
you can see like large ripple marks and like multiple rocks together, like obviously the layers.
yeah. Another thing I've just observed, there's not like much space in between them. Like they are pretty compacted together.
Yeah.
Is another
That's
thing
true.
to observe. Like there's not like gaps between them or anything. They are pretty compacted together. What would you expect to see in a sedimentary rock sample? Did we answer that one? No. What would you expect to see in a sedimentary rock sample from now on?
I guess
Actually-
layers.
Yeah, layers. It's a good one. Do you reckon in real life, like you would be able to see the different colors of layers, like for the
I think
mud
it depends
eroded?
on what was in it.
Yeah, it would
Like if
depend
they're
on
Material.
what rock.
they're the same color, then you probably won't be able to see it.
Yeah.
But if they're like distinct different rocks being mashed together,
Yeah.
Yeah, I think that's a good one. And then what do you need to look for?
I guess we kind of just answered that.
Yeah, definitely.
Yeah.
Alrighty, activity 2.
Well, let me do the final
Oh,
hypothesis.
yeah, sorry, Callum, I just jumped.
No,
the
you're right. So do you have the original one?
Yes. So
I'm going to read it out just once more.
if the 3 different Play-Dohs are compressed with pressure, then the Play-Doh colors will compress together because pressure is being applied.
All right. So we technically were kind of correct with our hypothesis,
Yeah.
but I would probably add the layers in.
Yeah.
And just talk about the compacted and cemented. as we saw in the experiment. So I would say if the 3 different Play-Dohs are put into a Ziploc bag, correct?
Yeah.
Callum, does
Ziploc
cemented
bag.
mean like they're put together, they can't come apart again? What it means?
I'm pretty sure, yeah. Oh, they can with force. But yes, I'm pretty sure they go into one.
Yeah.
Yeah. So I've kind of written down if the 3 Play-Doh Ziploc bags are put into a bag and layered together, then the pressure from is it a straw?
Yeah, straw.
Pressure from the straw will create sedimentary rocks because of the layers under layers, and then they'll be compacted and cemented to create one layer of rock.
Yeah.
Mm-hmm.
Does that make sense? Yeah, no, yeah. All right. Is everyone good with that? Want to change it? It's up to you guys.
No, that sounds good.
That's good.
All right. Sweet. Move on to the next one then.
Alrighty, activity 2. So it has work with the group to discuss what metamorphic rocks
I
are.
think.
What do they look like and how are they formed? So this has discuss these questions before you start. So
Metamorphic rock.
yes, what do we think they look like?
More like one color, or like the same size particles in one. Like if you were to cut it, you wouldn't really be able to see the difference in
Yeah.
the particles as much.
Yeah, it wouldn't have like layers in it. It would just have one solid kind of even. It has mixture of different things, but it looks all even.
Yeah. I feel like that's
I
right.
thought metamorphic rock was like that. It when the rocks are formed, they create a new substance. Like rather than it being like a mixture of substances, it like actually goes together to make something else. I don't know how to explain it other than
You're
that.
definitely on the right track.
It's hard to
Definitely.
explain what I'm
I
trying to
feel like
say.
the only time I've ever heard of like metamorphic rocks is like when there's been something like a volcano or something
Yeah.
hot.
Mm.
That's the only time I've heard of it actually as well, Rachel.
Yeah.
I haven't really heard much of it in other terms, anything like that.
That's good observation as well. In inferences.
How do we think they are formed?
Heat.
Yeah.
Yeah.
And pressure.
On the money.
Awesome. Alrighty. So we have to remove the small sample from the small cup, and it makes sure it says not the core sample, but the complete sample by lifting it out of the Ziploc bag. Make sure the Ziploc bag is sealed. You can all see that I have sealed the bag. I'm just going to actually release some of this air first. Alrighty, so that's what it kind of looks like at the moment, kind of in a little cup shape form at the bottom. And then we need to place the Ziploc bag, sealed Ziploc bag in a water bath. So I got my little water bath here. The water's still pretty hot, which is good. And then, yeah, so before doing this, discuss the health and safety aspects of it. So it has what instructions should the students know about transitioning to and from the water bath? So from the looks of this, the students actually do the experiment if they're looking at students know about transitioning to and from the water bath.
Say that once more.
Yeah, can you say that again?
What instructions should the students know about transitioning to and from the water bath?
Should they know about it?
Yeah, so what should they know?
Or what?
Oh, okay.
Right.
Yeah, definitely.
Don't touch the
This
water.
comes. Yeah.
Wear gloves, don't touch the water.
I think even maybe letting the
Is it-
people handle
Is
the
it what should they know in terms of health and safety or?
health and safety.
Yeah.
Okay.
Make sure like walking, no running.
Yeah. Then it said, should students use their hands to hold the bag or wooden tongs?
Obviously, wooden tongs,
Tongs?
I'm assuming.
Yeah.
Just so you can avoid the burning
Yeah.
or any accident.
Yep, that's a good one. What instructions should the students be told about putting the bag into the hot water?
Do it slowly.
Make sure it's splash.
Yeah, I think that's a big thing. It's not just like
Use tongs.
get in.
Yeah, don't drop it.
And
What,
if they do, tell the teacher so they don't reach and grab it.
yeah. What temperature should you use in primary schools to ensure it is still a low risk activity? Does anyone know?
Is it under 75? Or is it 60?
Must
I
be
feel like it's 60.
yeah.
Because I mean, this is 60, and it's not hot. Like it's hot, but it's not like it's boiling hot. Like it doesn't burn my skin.
Yeah.
But I mean, I am 22, so like it might not be hot to me, but it could still be hot for someone that is
Yeah.
younger.
Yeah.
So yeah, 60. I feel like that's a pretty good temperature. What else should be discussed around behavioural management associated with this activity?
I think it's the same thing like with the water, like having one person in the group, like getting it, or even just having the teacher have it already set up so that you minimize that risk of spilling or burning.
Yeah.
Yeah.
Yeah, just avoiding burning and just telling them, especially, well, I don't want to say consequences, but warning them that, it's dangerous.
Yeah. And I think with spilling too, like obviously if water's spilt, then they're gonna the floor's gonna be slippery, so they need to make sure they're walking as well and not running around.
Yeah, I might add that to our health and safety thing as well at the end. Just because we've discussed about it now, so I'll add that on as well in any points that we have here as well.
Yeah.
Alrighty, so does anyone else have anything else to add with that?
Do we need to have direct quotes, like say them in this, or is that just for like the PowerPoint that we just like put direct quotes? What was that for?
The direct quotes was for the health and safety at the very top. This is just like the health and safety like questions that they've asked.
Yeah.
Like if it
Throughout the document.
yeah, throughout the document. But like I'll transfer anything that we've just said here onto our health and safety anyway.
Okay.
Yeah. Okay, so now it has recorded what the sample in the Ziploc bag looks like before you put it into the water.
So can you
It's
take a
kinda-
photo of that too?
Yes.
Just a question. Did you get like a time you were meant to like mash it for, or did you just do whatever you thought?
It didn't give us a time to mash it
Like,
for.
the longer you do it, the more it's going to combine.
Yeah.
Yeah, so it just
How
says
do you
use a
tell?
press down pestle to apply pressure to the content, sorry. And then it says time to take core samples of each long cylinder.
Oh, okay.
So it doesn't really give you, because when I was doing the putting pressure on it, I was thinking in my head, I was like, how long am I meant to do this for? I just thought in my head, I was like, 20 seconds, 10 seconds, like.
Yes, how do you keep it a fair test for the next one you're doing?
Yeah, that's a good point. That probably maybe as a teacher, like you might have to allocate how much time you do spend on putting the pressure on. I think it's going to be hard to keep it a fair test if each kid is doing it and applying different amount of pressure.
Yeah.
I think since it's a modeling activity and you're not actually recording data,
Yeah.
it's as important to make it a fair test.
Yeah. Okay.
I think
if you have a discussion at the end, thinking like, oh, if we were to do this as an experiment, what would we do to make it a fair test?
Yeah, that's a good point.
I think also in your discussion at the end, you could say like, this group didn't apply as much pressure as this group did, like, and you can see the differences in what's happened as well.
Yeah.
Definitely observations throughout.
I think it's such a good experiment to get kids to like start thinking and start using their scientific
Yeah.
knowledge.
Definitely. Alrighty.
Alrighty.
Okay. After the Ziploc has been so we've all kind of seen what it looks like. I've taken a picture of it. It's kind of still like it's not fully compressed together, I would say, but there are it's all attached, but there are little gaps between some of the outside, like the edges, which could be the amount of pressure I applied. Like it wasn't too much more than that it all compacted together. Alrighty, so now after sealed zipper bag, we have to put it in the water for 2 minutes. So it has to be, I was trying to get my camera and like do this, and I'm just going to quickly grab my phone to time it. Start. All right, so it has to stay like that for 2 minutes.
This is a very long
Just during
step.
minutes.
So we have to go to 10 minutes, do we?
So we do it for 2 minutes now, and then I have to move the bag back and forth to side.
Yeah, wiggle it, yeah.
Around it. Then I have to remove it and squish it as much as I can, and then I have to place it back into the hot water, wiggle it around again for a minute, and then I have to repeat this till up to 10 minutes.
Okay.
Wow.
So it is a little bit of a long bit here. I might just move my camera down.
You'd need a fair amount of lesson time to do this.
Yeah.
Yeah.
That's
Or
why
even
maybe it might be something that the teacher just does for the student
Yeah.
rather than like every group doing it, because that would just be.
I can even like the first activity could be done in groups, but the second definitely a modeling activity.
Yeah.
Before you've done.
We're up to a minute, guys. Woo.
Is there anything that we can talk about while this is going on?
Just discuss the health and safety aspects associated with the touching the hot Ziploc bag. So I guess it's hot. It could melt on the student if it's too hot.
I think that's a good thing to use the wooden tongs to get it out of the hot water. But once you because you have to squeeze the bag with your hands. So I think the gloves might be a helpful thing to do there, to have the gloves on.
Yeah, definitely.
Again, obviously it's not really hot for me, so I can squeeze it using my hands and I don't have any gloves with me. But for little kids were going to do it, I would say they would need some gloves if they're going to squeeze it. All right, it's been 2 minutes, so I'm just going to stop it.
That might be another reason too, that it's more of just the teacher models it rather than them all doing it as well.
Yeah.
A lot of liabilities.
Yeah. So I've just removed it, and now it says squish it as much as you can into this squeezing part. I'm just squishing. All right. Do you think that's enough of the squishing?
As hard as you could.
Like the Santa Claus. Alrighty. So from what I can see, the colors, like there is a little bit, oh, my hand was in the way. The colors are still like, you can still see each color, but it's not like there's a bit of like green coming out of it.
So they're kind of changing.
Yes. All right. So now
And you definitely you can't pull that apart now. Like,
No.
you wouldn't be able to get the different colors out. All right. So I'm going to place it back into the hot water, wiggle it again for a minute.
I'm biting my tongue so much because I want to just answer it.
Keep wiggling.
Wiggling for a minute. I'm going to get an arm workout from doing this, or a hand workout, I guess I should say. So it has, make sure you comment on the look and the feel of the sample. So when I was feeling it, like, it wasn't difficult to squish, but it wasn't like the easiest, like as I thought it was going to be. Like I thought maybe because it's been in the hot water, it's going to be really easy to squish. But it wasn't as easy as I thought it was going to be.
yeah, maybe like the longer that it's in there, it'll get softer.
Yeah.
Or even the temperature. Because you put it at 60 degrees, didn't you?
Yeah, but it has been sitting here for a little
Yeah, that's what I was.
Yeah.
Like,
it might not be at 60 degrees right now.
Yeah.
It's definitely left the container lid on, but it's still hot, like when I put my hand in it. All right, it's been a minute. So then after a minute, repeat this step a few times till about 10 minutes has come up. So just quickly, so
10
squeeze it.
minutes, you're going to squeeze it.
Yeah. So it's definitely a lot easier to squeeze, and as you can see, it's still like it is mixing a lot better together.
It's definitely forming.
Yeah. All right, I'll let it back in that water. Stir for 10 minutes or minute.
Have you done your timer?
Yeah. So I don't know whether I have to like if it's 10 minutes it has to be in that hot water, or I just time it like now, and then I time like include the time that I'm squeezing it.
I think it's 10 minutes in total.
Yeah. Okay.
Yeah.
So I'll just leave it, and once it gets to like a minute 10, which is when I started it, I'll squeeze it again.
Yeah, this would definitely be a modelling activity.
Mm.
You'd be there all day with the kids if you tried
Yeah.
doing it.
Oh, yeah. Especially with the time.
Yeah.
To start. It's a lot of stop-start.
All right. Squeeze it again. So I can actually feel like the plastic bag is hot when the Ziploc bag, but again, it's not hot for me. It's more, but like it could be hot if they were to touch it. All right, I'll give you a little look. So you can kind of see the colors. This side's probably a little bit better. The colors have started combining together.
Yeah.
Wow. Keep my stirring. So much fun.
The other side started to look purple.
Yeah, I don't know.
Yeah.
Maybe because like the way I'll alternate the way I'll just flip it around a little bit, maybe. So it's just make sure it's fully submerged. I'm like trying to keep my head in it, but like it keeps standing up. So I'm like, so if I'm talking and you can't see my head, let me know.
We can hear
Oh, that's
Yeah.
a good thing, I guess.
you.
So you can definitely see the colours are mixing together.
Yeah.
Morgan, did you want to make up the should we make up the
Observation.
worksheet that we were going to do?
Yeah, so do you want to do like one for the first?
Right. So you can see a little bit
Yeah.
of pixel in it.
So they can draw what it looks like at the start, and then they can draw like what the sample looks like.
Yeah.
So you have 2 spaces.
Yeah.
For it.
So I'll do the first experiment and you'll do the second.
Is it just going to be the same thing? Like for
I
the
reckon
second one?
Getting them.
Yeah, it would be. Either do they just do the same thing? Sorry, I'm gonna have to turn my phone
Getting
off.
them to actually draw them would be pretty cool. Like the before sample and then the after sample.
Yeah.
Yeah, I think what we were saying is like they can write what they think's gonna happen and then they draw what they see.
Okay,
Yeah.
no, that's cool. Yeah, I like that.
I'm going to do like a...
Is that fan too noisy or is it fine?
No, can't hear it.
Can't hear it.
Again.
How's the wiggling going?
Oh, good fun. Oh, it's really gone like pretty green now. You guys a quick little preview.
Yeah, right. Look at that.
So
Oh wow.
it's gone green. Dunk it back in that water. Well, we're up at 4 minutes, guys. Only 6 to go. Feels like it's been 10.
Yeah, patterns. I guess they're forming together
Yeah.
due to the water.
If you wanted to as well, like in the classroom, if you wanted to include technology in this assignment, you could get them to do the data observation on like their iPads or their computers and like take photos.
Yeah.
And then they could even do like a timeline as well with the photos of how what happened over time.
Yeah, that's a good idea.
Yeah, it's a good idea.
Just thinking if you want to include technology as well.
Even on my prac, OneNote was very popular.
Yeah,
They could upload photos to OneNote
yeah.
before, after, during, or even like timed 1 minute or every 2 minutes, like we're doing.
Yeah. They could even do that in their books too, though. Like the teacher could hold it up and be like, "Oh, this is what it looks like after 1 minute," and they could quickly scribble it down, like what colours like it looks like, and then this is what it looks like after 2 minutes, and they could do that.
So I'm on.
What does it look like now, Kate?
It's like bluey greenish.
Yeah, definitely just a blog now.
No pink anymore.
No, there is a little bit of pink, but like it's not. I wouldn't say as much as like you think it'd be. Not as much as.
Do you think the water makes a big difference, or is it just the squishing?
I think both, but I think mainly the squishing because you are squishing it
Yeah.
together by force. But yeah.
Yeah, I'll go through the CDSU after we do the final hypothesis.
Yeah.
So we all understand.
Should we start talking about the final hypothesis?
Yeah, sure, we can. So what was our original one? Oh, you're kind of busy.
It's all right. I can multitask. It was if heat and pressure are applied to Play-Doh, then the Play-Doh colors will combine to one color because the consistency of the Play-Doh has changed.
That's pretty spot on. Only thing, obviously, metamorphic rocks, when they are formed, so from igneous and sediments, they're changed due to heat and pressure, like we've discussed. And when they're put under heat and pressure, they're chemically changed. So they're forming new rocks, which are metamorphic rocks. So
the
basically,
heat and pressure changes the chemicals in the.
yeah, to form metamorphic rocks. Yeah. So you need heat and pressure. Heat's coming down and pressure's coming from the Earth's crust, and it forms the rocks in the middle.
Oh, that's why I've heard about it from volcanoes then.
Yeah, I know. I had to bite my tongue when you said it.
Yeah.
That sounds
I just
pretty good. Go
did
on.
like a little thing for recording the.
In Teams.
I'll just share my screen and then I'll put it in Teams in a second.
Okay.
Can you see my screen?
Yeah. Yes.
Oh gosh, it keeps changing. So I just put in up the top there. They can write what they think is going to happen, and then they can they have space to write what it looks like, and then they have space to draw what it looks like as well.
That's really good.
And then underneath they can write like their final hypothesis, what actually happened,
Wonderful.
and compare it to their predictions at the top.
Yeah, that looks great.
Cool. I'll put that in Teams. I'll just save it, and then they can do that for the first activity, and then again in the second one it's like the same.
Yeah.
And we'll just add like heat to this part here. Yeah. Okay. Alright, where did that go?
Well, the water's definitely gotten a lot colder, I would say, like from the very start, which could also have a little bit of effect on.
Can you attach Word documents in the chat?
I think you might have to. I think you might have to copy and paste it into the
Yeah.
Oh, okay. All right.
All right. I've got 10 seconds left. So I'm just going to squeeze for the last 10 seconds. That is 10 minutes on skis. Alrighty, so I'm going to quickly wipe this down. My blanket.
I'm just going to say the last hypothesis out loud again. Just reread. So if the 3 Play-Dohs are put under high heat and pressure, then it will create metamorphic rocks, because when layers of sediment and igneous layers are placed under heat and pressure, they will chemically change their forms into metamorphic rocks.
Yeah.
Happy with that?
Yeah.
Yeah.
Alrighty, so this
Sweet.
is the end product.
Yeah, look at it. It's completely changed.
So it's definitely all the colors have kind of combined together, and you can't even it's not even layered or anything. It's just kind of
Oh wow.
one. But I wouldn't even say it's one color, because you can still see like green and a little bit of blue, but it's not like it's. And on this side, there's a little bit you can see. There's a yellow and pink.
Pinks and yellow.
But on the whole thing is mainly that green blue color.
Yeah.
That can be for an observation. Right now, so it says, after 10 minutes, gently press on the sides of your sample and try to make it into a cylinder shape. I will do my best. Oh, no, that way, let's go the other way.
Just ignore that, Prezi, for a while.
All right. I tried my best to make it into a cylinder shape.
Did you manage to copy and paste it, Morgan?
I just uploaded the file onto there. That's got it in it.
All right, now it says, open the Ziploc bag and take another core sample by pressing the straw gently into the cylinder shape. I'll just move my camera down a little bit. Move gently. Oh, that one didn't really work. I'll try again. There we go. So this is the first one. So you can definitely see that it's definitely one color and there's not layers like there was before.
Yeah.
It's definitely chemically changed.
Yeah. Right, and then it has, using your last straw, take another sample. Let's do that. Oh, that didn't work. I'm sorry. See if this one works. Oh, it's half hanging out, but. Yeah, and then let's observe and describe these core samples.
They look very similar.
Yes. So looking for patterns, I guess they both look the same color.
I guess that's really kind of seeing the same thing.
It's interesting that that's the color that it turned out to be.
Yeah, I mean, if you look at, these are the original ones, and then if you look at these ones, you would think, I don't know whether it's the colors that were chosen to make it go this greenish color.
Yeah.
There was lots of blue to begin with, though, wasn't there?
Well, I tried to make
They
they used the grey.
Yeah, that grey could, I reckon the colour choice could definitely affect it.
Yeah.
Yeah.
I mean, I tried it, and again, you couldn't really test unless you calculated how much grams of each Play-Doh you put into Ziploc bag. I just tried to put in the best that I could.
Yeah.
Estimating, but it doesn't say whether you had to make sure it is really even, I guess. It wasn't in the instructions, it wasn't saying you had to measure it out or anything. But again, if you were trying to make it a fair test, you would have to measure how much grams of the Play-Doh you're putting in. And then it says, write your final hypothesis by linking your inferences with observation.
I guess we kind of did that already,
Yeah, done that.
which is good. Tick.
Yeah. What did the hot water represent?
Heat.
The heat.
Yeah, heat, I would say as well. What did the squeeze represent?
The what?
The what?
Squeezing.
Squeezing.
The
Pressure.
Pressure.
yeah.
Where do you think the pressure came from? This is just like a general question for me. Where do you think, like, what do you think the squeezing like represents really? Like the pressure of like what? Do you
The
Could be water. Could be air pressure.
yeah.
Could be anything.
Why did we do this a few times? What was the reflection? What was that reflective of?
I wish you could discuss the fair testing.
It's isn't it a reflection of weathering and erosion? Like
Yeah, over time.
over time, yeah.
Yeah.
Freezing it and then having two samples. Based on what you have observed, could you now identify a sedimentary or a metaphoric rock sample?
Yes.
Yeah, definitely.
Did these activities help you understand the difference between sedimentary and metaphoric rocks and how they are formed?
Yes.
Yes.
Will the difference between the two rocks be easier to understand now?
I would say yes.
Yeah.
Awesome. All right, that is the experiment done.
Yay.
Took us a little while, but
All right, Callum, you're up.
Time for how do you share screen?
The button
Just the
next
button.
to the leave button.
All right, share content. Loading. Get ready for an exciting presentation.
well,
Can't wait.
It's just loading. Can you guys see anything?
No.
no.
I might have to get who's shared
Do you want-
screen.
Do you want me
Yeah,
to try
yeah.
and
Could
do
you do it? Yes, please.
Yeah, what computer are you on? Because mine denied access, which is weird.
Mine's on Mac.
Yeah, me too. Wouldn't
I'm on Mac.
maybe my settings
Well,
are
it's in
different.
the Teams chat. Could someone pop it up for me?
Yeah, I've got it. I'm getting
Sweet,
it.
thank you.
Just give me
Appreciate
one
that.
sec. Where am I? Where am I? So there we go. Hang on, I just got to find where I put it.
God, it's annoying.
It's
Working?
coming.
Ah, sweet.
There it is.
Just tell me when you want me
Yeah.
to change it.
Appreciate that. So yeah, obviously we are talking about rocks in the rock cycle. I'll wait for it to pop up.
Sorry, money. There we go.
It's all right. So yeah, the cycle. You can just go next.
Still loading.
Yeah.
Yeah, it's gonna be a.
Technology, hey?
I know, I love it.
All right. There we go.
Sweet. So yeah, the rock cycle. It's important. Discusses the relationships between different rocks and how they change over time. If you go to the next one, there's a little diagram of that. Obviously, we have our igneous rocks and then our sedimentary rocks we're looking at, and then our metamorphic rocks. And if you do look at the arrows, you can see the heat and pressure. That's all right. You can go next. You can go next.
All right.
Next again. All right, so sedimentary rocks. They are formed when sediments, so sediments are rocks and minerals. They're deposited out of air, ice, wind, gravity, and bodies of water. And then their particles and create sedimentary rocks. There are two pictures. So when we're discussing before the layers, you can actually see the visible layers,
Mm-hmm.
which is pretty interesting. And then the first one is multiple rocks being put together. Next. So there's 3 types of sedimentary rocks. So clastic, which are made up of pieces of pre-existing rocks. So that would be our pebbles we discussed. Then we have chemical. They're formed when rocks or bodies of water evaporate. And then there's organic, and they're made up of living creatures, and they accumulate to form the rock. So the top left one is organic. The bottom one is a clastic, I'm pretty sure, and the top right is a chemical. Sweet. And then some processes and formation, as we discussed before: erosion and weathering. There's dissolution, precipitation, and lithification. The most common ones are weathering and erosion and lithification. We obviously discussed that in the activity. So the process of sediments, like I said, the rocks and minerals, they compact under pressure in bodies of water, and they become sedimentary rocks. So as we discussed the compaction and cementation, so as you can see in the photo, the groundwater compacting, and then it compacts and then cements into the sedimentary rock. And weathering and erosion is pretty straightforward, but weather, wind, rain affects rocks to break down, and then they fall down, transport into bodies of water, and then that process kind of starts with lithification. Moving on to metamorphic rocks. So they're a result from environmental conditions, and they change due to heat and pressure. So there are 2 types. Foliated, they have formed in environment with directed pressure or heat, and non-foliated, which are without directed pressure or heat. So you can really tell the lines of the first one, how the heat really squished them together. And then if they're not, it's kind of everywhere, which is pretty fascinating. So next, please. So yeah, as we looked at heat and pressure, that's how they're formed. So great temperatures and great pressures. Occurs near the Earth's crust. So like Rachel said, the magma and that. And an important note is they do not melt, they change forms. Next, please. And then creation. This is a really good diagram, what I was trying to explain before. But the pressure from the surface rocks, or the water, pushing down, and the heat from the Earth crust pushing up. In that middle, it creates the metamorphic rocks. It is important though, like I said before, if they do melt, they become magma, and it results in the cycle restarting. So, yep. And then, restarting the cycle. I cannot read that. There we go. As the metamorphic rocks are exposed to weathering and erosion processes, it will break down over time into sediment rocks, as we saw in activity 1, and then it will start again and again, and just over time. And last but not least, any questions?
So sedimentary rock can then turn into metamorphic rock, is that right?
Yeah.
Yeah.
Basically, the rocks will go down with the bodies of water and be compacted. And then the pressure from that water takes those rocks, and then the heat from the Earth's crust starts to cement those rocks, and they make metamorphic rocks.
Right. Okay.
And they'll start to go back up, and basically just keeps going around. But over like long periods of time, though.
Cool.
Sweet. Is that all? Yeah?
That was good,
stop sharing my screen?
Yeah, you can stop. Yeah.
Yeah, that was really good, Callum.
That's the CDSU done. I guess we can talk about the LHS. Yeah.
Yeah, I think that's Claudia. I think you guys are the LHS.
Yeah. So should we go through those 5 questions again?
Yeah.
I've done a PowerPoint up just with like the headings of like the ones that they did last week as well, just not like different ones, like they did alternative conceptions and keeping
put it on
tests. me to put it on?
Yeah, so we can all like kind of look at it.
I haven't filled it out
Not
yet.
now. Oh, not now. No, not now.
Oh, yeah.
So I can add
Yeah.
stuff later to it.
Yeah, of course. So, do you want to go through the 5 questions first
Sure.
that we could get asked? Grab that up.
I think as well in the LHS we have to talk about what we've learned, like the collective learning that we've learned about what we've done,
As
and
in everyone separately.
like that has to go in the LHS.
Yeah, in the
I
presentation.
think they really want like a pedagogy and then your science understanding of it.
Yeah.
How that understanding affects your pedagogy kind of thing.
Where are the questions? I cannot find them.
I think the first one's about the Australian curriculum.
Yeah, I know that. I don't know where they are though.
Yeah, links to ACARA.
I guess we've
And then
kind
it's
of.
student differentiation.
Does anyone
Um,
have questions?
Yeah. So how does the activity link to the Australian curriculum?
So I'm just trying to find.
So this would be talked about in multiple grades, wouldn't it? But in multiple levels, or I'll go into ACARA and find the exact.
Yeah, I'm having a look now.
I had a look at one. It was Earth's surface changes over time as a result of natural processes.
Yeah.
Yeah.
Just kind of spot on. I think it discusses rocks and, these are natural processes that are happening to the rocks.
In the year 3 one, there's also a change of state between solid and liquid can be caused by adding or removing heat. Like I know it stays a solid, but it like maybe when it goes to molten liquid as well. So that would be from the heat. That's one that works.
So Callum, the one that you said, is it grade 6?
It was 5 or 6. It was one of them.
Was it?
It's the little code for it.
Is it ACSSU 096?
It's where is it? ACSSU 075.
07.
It is. It's year 4. It's year 4.
Oh, okay, yeah, because there's one in year 6 as well. It says sudden geological changes and extreme weather events can affect the Earth's surface.
That could
I guess
definitely
that's
be one.
more about like natural disasters and stuff like that than.
But metamorphic rocks, can be affected by environmental changes. So we could discuss that. Because my elaborations in the year 4 one discuss extreme floods and weather. So
Yeah, this talks about earthquakes, volcanoes, tsunamis, blah blah blah.
Yeah, I think grade 3, 4, and 6 is the ones I can see main ones about rocks and property changes. So
so that's kind of covered. I guess we kind of discussed the health and safety in depth
we've
already.
We've done a lot about health and safety.
Yeah, we'll just elaborate it, especially the what the teacher says in that RHS.
Well, third question, the diverse learners one. I can't find the question.
So it's how would you cater for diverse learners in this activity?
So
I think the roles, like having roles in the experiment.
I think the sheet's really good, the results sheet, because it depends on like what level you're at. You can write, you can draw, you can
That's
do all
good.
kinds of things. Go into heaps of detail. You can write one words.
It's very
And I
can
think
use differentiation in that.
as a modelling activity, it's also important to explain what's happening in a way that all your students are going to understand as well.
Yeah.
Definitely.
You could use exit slips to check for understanding.
Yeah. We could also do some like extension activities for gifted students, like if they find that they could go higher than that.
Yeah.
Definitely making sure we're challenging all students,
Mm.
whatever level they are at.
Yeah.
I think the next one's how would you assess this activity?
Yeah. I think Rachel's talking about doing the formative assessment
Yeah.
with the worksheet that Morgan has created. So you can always look at that for assessment, even just doing observations of what the kids, how the kids
Yeah.
are doing it, like what listening to their discussions they might have.
Yeah.
How
I
they're
think
processing it.
questioning them
Discussion is
throughout.
good too.
Yeah, asking
Yeah.
them questions to see if they can explain what's happening like throughout the
Yeah.
experiment. You can use that as like observational and like diagnostic kind of
Yeah.
assessment as well.
Mm.
Writing it in.
And I think the last one is the CDSU, which if we do get asked, I can just say
Yeah.
it.
Jump in.
I'll just put in like some screenshots of your presentation. as
Yeah.
well.
But basically, I just said allowing students to physically see the changes will
Yeah.
allow them to understand better.
Yeah, that's good.
So we really need to talk about our scientific understanding and what we've learned from this.
I guess, well, I can say I learnt the difference like between sedimentary and metamorphic rocks, like
Yeah.
what they are and how to tell the difference between them.
Yeah.
Yeah, that's to say, it really opened your eyes on like how you can tell the difference between the two. Like seeing it actually, like seeing the sediments like they're layered and they weren't all combined, whereas the other one it was all coming all together. So I think that was really important. I think that will like it's really a helpful way for the kids to understand it. Like I think they'll understand it better seeing it instead of just
Yeah.
it.
And I think also like seeing that process of how the metamorphic rock is formed,
Yeah,
like you
definitely.
can see the change from one to the other.
Yeah.
I think that's
Especially, seeing, in general, the rock cycle. Kids
Yeah.
might not know what, rock cycles are, and
Yeah.
being able to
Yeah.
understand the processes that are within it are it's a pretty cool experiment, I thought.
Yeah. I
so
agree.
in terms of pedagogy, like how would you go about like using this in the classroom, I guess, or like what would you
I think you'd always want to try and make it really relevant to them, so you could even like talk about what things they have nearby and like how that would happen near them.
Yeah.
Yeah, that's good actually. Yeah, really good.
Really
I like
good.
mountains and stuff, and
Yeah.
That's something that you could even
favorite
like
parks.
take them on like or organize like a field trip or something
Yeah.
like that. And even like you could bring samples back from your field trip to take it to yourself. Yeah. Something like that you could like. But I think
then like talk
I
about
think
recent weather events and stuff as well, how
Yeah.
that might
Yeah.
have affected things.
I think like the main thing about this with like the pedagogy is just using that visual like representation to help with the understanding rather than just like explaining it.
Yeah.
It's very hands-on, which I
Yeah.
like.
Well, yeah, the kids actually really get to like see it, like how everything changes and everything like that. Instead of just putting it on like a PowerPoint and showing them pictures of it, they can actually like physically see it in their hands or in the teacher's hands.
I think you develop a better understanding as well when you can see it actually happening.
Yeah.
And it also encourages the students to like communicate what they can see. So
Yeah.
it encourages them to be part of the conversation and the learning as well.
Yeah.
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 All right.
So are we putting all of this into a PowerPoint?
Yeah, I'm currently just.
I reckon like last week, how they had it was pretty. I liked it.
Yeah. I
The
think
mind
like
But maybe
CDSU, rather than putting in like screenshots of Callum's
I reckon if we
Prezi, you just kind of like put some dot points in there about
Yeah.
like the main points.
Yeah, I think
I can, if you put it on Teams, like the actual PowerPoint document, I can add stuff to it to make
Yeah,
it
we
easier.
can all kind of add things to it. And then with
Yeah.
the pedagogy part, it just like
Don't
one
do,
main statement kind
Yeah,
of
yeah,
not
don't
talk about.
individual ones.
don't do individual
Okay.
pedagogies.
No.
Yeah.
Yeah, individual.
And then
But
we don't
we can all edit it though. We can all put it in.
Yeah.
We've
We
all
don't
kind
need
of agreed with each
answer
other
all
anyway.
those- Sorry.
Yeah.
We don't need to answer all those questions in the PowerPoint either, because then she has nothing to ask us.
Yeah, I think she was a bit. Yeah, I
So
completely
maybe
agree.
like putting in,
I like the alternative concepts.
yeah, I think that's good.
Discussed.
Like the CDSU,
What about
and then kind of
full
like,
questions to task?
Yeah, I like that too. Yeah, maybe not even like the assessment, definitely. But
I think
probably
maybe
don't-
the health and safety should go in there.
Yeah,
So
Yeah,
these
definitely.
titles that I've currently got. So I've got the Australian curriculum. How would we assess it? Then I have the CDSU assessment opportunities. Oh, that's the same, I guess. The ACARA. I've already said that.
I think
I reckon we could.
something that we
leave
can,
the ACARA out.
yeah, I think maybe you can
Right.
leave the CARA out and also leave out like the diverse learners stuff, because that's something that we can kind of easily explain.
Okay.
Yeah.
Keeping it a fair test, because she's not really going to ask us that, is she?
Nah,
No.
She
I
does
think if we don't
like
have,
modeling activity and not a data like recording experiment, so it's not,
Maybe we don't add that.
yeah.
Do you think she'll be okay if it's not there? Will she think that we've missed it? Or will we left it
I
out?
think she'll.
If
I think
she-
she'll ask. That's
If she
why.
has a problem, she can just ask, like,
Yeah.
those-
So then I've got pedagogical understanding, catering for diverse learners, health and safety, and then
We can
So,
do like
yeah.
an overall statement as well, saying.
and then
like,
what did we learn at the end?
Yeah, I was about to say you might
Yeah.
want to put the scientific understanding or knowledge in it as well.
Yeah, definitely.
So maybe like the first part should be the assessment or the
Yep.
CDSU and the alternative conceptions, and then the next part should be our scientific understanding and then how that informs our pedagogy.
Yeah.
So like then we have space to answer her questions as well.
Yeah, I think that's what they did last week. They just did the CDSU.
Do you want to stop recording?
Oh, yeah.
I just thought
So,
you might be
we only have